Basically, we will first see the two basic practicals, and then we will move on to the next practical. So we have already done this on the virtual lab. Let's try doing this in the multi-C. So now we are studying OPAM, operational amplifier. So let us select the operational amplifier 741. Okay, so go here. Is my screen visible to you?
Yes, ma'am.
You can refer the pinout diagram of IC 741. So pin number 1, 2, 3, 4, 5, 6, 7, 8. So it's a 8 pin IC. Pin number 1 is offset null. Why for this pin is used? Because you know the op-amp, there is the error voltage generated at the output. So if you want to nullify that offset voltage, so you can use this pin 1 for nulling the offset voltage. Then pin number 2 and 3 are input pins. So 2 is inverting. So if you apply here a signal, you will get a inverted output. Pin number 3 is non-inverting. You know it now. So if you apply your input at pin number 3, you will get a non-inverted amplified output. Pin number 4 and 7, they are supply voltage pin. So 4 you have to connect minus VCC, and 7 you have to connect plus minus VEE at 4 and plus VCC at pin number 7. 6 is output, and again 5 and 1 they are used for offset nulling. Pin number 8 is not connected. So it is simply there to have a look, a symmetrical look. So pin number 8 is not connected. NSIM is not connected. So I have selected here IC741, and we will see the inverting and non-inverting configuration first, and then we will uh, implement triangular and square wave generator. OPAM has a triangular and square wave generator. So this is the IC. Just now we have seen the pinout diagram. So let's apply input signal here. So I will use a function generator. So this is a function generator. Let us use here select, which is AC, and make the frequency of that signal is 1 kilohertz. Okay, so frequency is set to be 1 kilohertz. Duty cycle let it be 50, and amplitude make it 1 volt. So 1 volt peak. Okay, means in the peak from 0 to positive it will have 1 volt, and from 0 to negative it will have minus 1 volt. So 2 volt peak to peak or 1 volt peak. This is the setting, and let us apply it to the non-inverting terminal. So this is the non-inverting terminal I have applied input. So go to place analog and use 741 IC. Setting is not disturbed. Yes, it is. So it is connected to the non-inverting terminal. Now, how you connect the inverting terminal? So let's use this resistance 1K. So, annotation. So, there is R1 and RF. So, where you connect R1, you connect R1 to the inverting. You connect R1 to the inverting terminal and other end of R1 is grounded. So, I'll place a ground from this. This is ground. I have grounded this. So, now my whiteboard is started. So, this is Opamp. If you want to use it as a inverting configuration, negative terminal, positive terminal, that is inverting and non-inverting terminal. So at inverting terminal, we used to connect here R1, then ground this, then connect feedback resistance between inverting terminal and the output terminal. So here is your feedback resistance. This is connected to output. So this is your output. You are connecting dual supply plus VCC and minus VEE. Now I said it's a non-inverting configuration, so I must apply my input to the non-inverting terminal. Okay, so R1 and RF. So let us decide the gain. Let's design. So let the gain to be 10, so that my output will be amplified by 10. So you know what is gain of inverting op-amp is 1 plus RF by R1. We have seen this 1 plus RF by R1. Okay, now let R1 equal to 1K. So in order to have gain equal to, in this case it will be 11. If I want gain equal to 11, then 1 plus RF upon 1K. So 10 is equal to RF upon 1K. So RF is equal to 10K. So this way I can design. In order to have gain of 11, I need to have RF equal to 10K. So now this is my R1, this is RF. So let's see it on multisim. But in this figure, I have shown this terminal upward and this terminal downward. Now my IC said that positive terminal is upward. So now you know, to the positive terminal, non-inverting terminal, we have to apply input signal. So that we have applied, and now ground this signal. So I will take this ground. It's grounded. If anybody is there in the waiting room, please let me know. Okay. So now where to place second resistance? I'll simply copy this resistance and paste it here and make it 10 kilo ohm. I will edit its value. So I have 10K. So where to connect 10K? It's RF. So it is between this and the output. Okay. So connection I made. I have to connect supply voltage. Okay. I have to connect supply voltage. So what are the pin to connect supply voltage? I must connect negative voltage to pin number 4. Negative voltage to pin number 4. So where is my pin number 4? Here. Here I am supposed to connect negative voltage. So let's take the power supply, and you can get directly VCC and VEE. So I have taken this. This is basically minus 5 volt. So let's make it minus 15 volt. Are you following the steps? Or you can use another, you can use this source also. Okay, so in that case, you have to connect the negative terminal here and ground the positive terminal, right? This is positive terminal that I will ground, and negative terminal I will place at pin number 4. Or you can use directly minus VE and make this as 15 volt. So let's rotate this and connect it to pin number 4. Similarly, I'll take VCC and I'll edit its value 5 to 15. So plus minus 15 volt power supply I'm connecting. Now I can connect here to pin number 7. Okay, so now this is ready. How much voltage I have applied? See here, 1 volt. Now to observe, let's use a oscilloscope. So I will use channel A to watch the input signal. So I will connect here to the input signal, and this is to the ground. Then channel B I will connect to the output terminal, and this is to take a ground. I'll change the color of output to, let's say, green. Now let's run the circuit. I'll maximize this output. I'll maximize the CRO, and green color is our output. So I will reduce its frequency so that it will be visible to you. And I'll simply pause this. तेजस सोनोने, Tejas Sonone, are you there? I have stopped the execution and this is the waveform. This is what output signal. Now look at the input signal. It appears to be straight line. How much was the amplitude of input signal? 1 volt peak. And here we have connected it to channel A. Input कुठे connect केलाय बघा, channel A ला connect केलेला आहे आणि त्याची value आहे 2 volt peak to peak or 1 volt peak. So and here it is 5 volt. Scale is of 5 volts. I will reduce the scale for channel A. AC. Now here both signals are appearing. So input is connected at channel A and I have shown it by red color. This is channel A, red color line. It is connected there. And how much it is? 2 volt peak to peak. So and its amplitude shown here is 10. So I will reduce it to 1 volt. Okay. And output, how much output is expected? What is the gain of this amplifier? We have designed it for gain equal to 11. So output will be 11 times the input. Okay. So if can you see this window? So I will pause this. So let's measure the input. We have given 1 volt peak to peak. Let's say how much we are getting here actually. So cursor number 1 I will bring to the this lower peak and cursor number 2 I will bring to the higher peak of red color waveform. Okay, so how much measure here? Look here, channel A. Look at the cursor. Shall I reverse the color? Is the screen visible to you? This is better or previous is better? Which background is better?
This
Red
background.
or okay, this background. So I brought cursor number 1. Anywhere you can bring. This is the lowest peak. So look here. I brought this point here and cursor number 2 at the highest peak. So it will give me positive value. So I am getting it 1.992 means 2 volt. And that is correct because we have provided 1 volt peak means 2 volt peak to peak. So this voltage is peak to peak voltage. You have to note it down. Then output voltage. So which is your output voltage? Output voltage is green color. Now can you observe that wherever there is an red color peak, that is positive peak of input, so output is also having positive peak. Whenever there is negative peak, output is also having negative peak. It means the input and output both are in phase. So it is a non-inverting amplifier. That is why your input and output both are in phase. Understood this? Yes or no? Hello. Are you getting? Inverting out op amps, input and output, you can observe both are in phase. Look here, both are having For the positive half cycle of input, you are getting positive half of output. For negative half of input, you are getting negative half of the output. And we have adjusted the scale here, and you see that amplitude of output is higher than input. So amplification has done. Now just measure the output. Please tell me whether you understood in phase relationship observed at the CRO.
Yes, ma'am.
Only pager understood.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. And now let us measure the output. So same way you can bring the cursor 1 to the lowest peak of output. I have pressed here ground button so that you will observe only output. See this ground button. So channel A is grounded. It means that input is now disappeared. Only line you can observe. So I can easily measure this. So one cursor number 1, I placed it at the negative peak, and cursor number 2 to the very next positive peak. So this high going signal I get here as minus 21.90. I think I have reversed. Yes, I have reversed this. इथे तुम्हाला -21 का मिळत आहे कारण मी पोझिशन कर्सर 1 and 2 ची चेंज केलेली आहे. सो यू कॅन राईट इट एज 21.95. कर्सर 1 मी आता इथे आणते नेगेटिव्ह पीकला. इफ युअर कर्सर 1 is at negative peak and cursor 2 at positive peak, like this, cursor 2 at positive peak. So this, you are going from negative to positive, higher rise. So this will give you here positive sign. And if you reverse the thing, it will like if you keep your cursor 1 at negative and cursor 2 at positive. आता काय केलं मी कर्सर 2 ला नेगेटिव्ह आणि 1 ला पॉझिटिव्ह आणलंय म्हणजे आपण 1 to 2 येताना असं डाऊन येतोय. इट मीन्स नेगेटिव्ह. सो बेटर 1 जो आहे हा नेहमी नेगेटिव्ह पिकशी दाखवा आणि 2 पॉझिटिव्ह पिकशी दाखवा. आणि दोन्ही सिग्नल इथेच असेल तर you can observe both simultaneously. So now what is the amplitude of output? 21.90. It's around 22. आपला गेन किती होता सर्किटचा? How much was the gain? विसरलात का रे? किती होता गेन? How much was the gain?
11.
11. So I must get output 11 times. What was my input? 1 volt peak, right? ही जी व्हॅल्यू आहे ही पीक टू पीक आहे बरं का. ही जी व्हॅल्यू आहे 21, इट इज पीक टू पीक. सो आय हॅव गिवन इनपुट सिग्नल ऑफ 1 volt peak or 2 volt peak to peak. जर 2 volt peak to peak असेल तर multiplied by 11, so I must get 22. So I am getting here approximately 22. कर्सर पोझिशन आणखी शार्प केली की तुम्हाला 22 मिळू शकतो. सो gain was 11, input was 2, so we got the output approximately 2 volt sorry, 22 volt, and so now you can observe both inputs and output. इनपुट किती आहे तुमचं बघा इथे, आपण कर्सर ऍडजस्ट करून ठेवलेलं ऑलरेडी. सो यू गेट around 1.99 volt input, म्हणजेच 2 volt. So and you are getting output 21.9, that is approximately 22 volt. So again, what you are supposed to do, take the screenshot of this, paste here, paste it in the word file. This is the screenshot of result. And before that, I will put here circuit diagram. So have you observed? This is the circuit diagram. So again, and then you can perform the calculations, relation between input and output. Okay. Now what I will do, I will make a change in this. Then inverting configuration करूया आपण. I have stopped it now. So you know, in the inverting configuration, we have to apply input to the inverting terminal. Okay, so I'm cutting these things now. I will keep the resistance as it is. आता इनपुट कुठे अप्लाय करायचं आपल्याला, इन्व्हर्टिंग. आणि इन्व्हर्टिंगला कसं अप्लाय करतो आपण, वी अप्लाय थ्रू द रेजिस्टन्स. सो आय विल कनेक्ट दिस इन्व्हर्टिंग this input to the inverting terminal through resistance R1. Our feedback resistance RF or R2 is 10K. Again, it is connected here. And now what to do with pin number 3? Pin number 3 ला काय करायचं? इनपुट इन्व्हर्टिंगला दिलं, पिन नंबर 3 ला काय करायचं?
Ground.
Ground. You cannot keep any terminal open. याला ग्राउंड करायचं. Okay. Again, I will connect input. So this is the input which is connected here. Input terminal. Yes, a second terminal will connect to, let's say, ground. Let's run and observe what you are observing now. I will pause it. आता काय ऑब्झर्व करताय तुम्ही? रिलेशनशिप. We have connected input to the inverting terminal. तर output जे आहे आता green color, you see what you observe, when input, the red color input, it is having positive half cycle, the output is having negative half cycle. When input is having positive half, output is having negative half, right? So this is 180 degree phase shift. कितीची phase shift आहे? 180 degree phase shift. So you will find gain. आता gain किती असायला पाहिजे या केस मध्ये? What is the gain of inverting amplifier? Opamp inverting amplifier? Formula सांगा. Yes. Inverting amplifier चा gain चा फॉर्म्युला काय आहे? What is the formula of inverting amplifier's gain? Everybody, हा कुठला एम्प्लिफायर आहे आता मी जो दाखवते तुम्हाला?
Inverting.
हा इन्व्हर्टिंग आहे का? Tejas?
This is non-inverting.
This is non-inverting because I have connected input to the non-inverting terminal. If you want to convert it to inverting, your input will go here and this terminal will be grounded. जर याला नॉन इन्व्हर्टिंग करायचं असेल, याला इन्व्हर्टिंग करायचं असेल तर इनपुट जो आहे तो इथे येईल तुमचा आणि हा जो टर्मिनल हा ग्राउंड होऊन जाईल. ओके, सो इन दॅट केस व्हॉट विल बी द गेन? गेन ऑफ ओपॅम्प इन इन्व्हर्टिंग कॉन्फिगरेशन. इथे मी एवढं हायलाइट करून ठेवलंय तुम्हाला नॉन इन्व्हर्टिंगचा गेन. याच्यावरून तुम्हाला इन्व्हर्टिंगचा गेन नाही आठवत का?
minus RF upon R1.
Very good. It's minus RF upon R1. So what is your RF upon R1? RF तुमचं या केसमध्ये आपल्या 10 आहे आणि R1 1 आहे. Because we have used here RF equal to RF is 10 and R1 is 1. So gain is minus 10. So your output will be amplified by 10 and negative sign indicate that it is out of phase. So now let's bring the cursor. Cursor number 1. Input घ्या. Inputच्या negative terminal ला cursor number 1 and cursor number 2 to the next positive peak of this. Okay. So input is plus 1.9, that is approximately 2 volt, and output is 19 minus indicate the phase reversal, minus 19.889 means approximately 20. So 10 times your input is getting amplified. This is non-inverting configuration of op-amp. Sorry, this is inverting configuration of op-amp. Let's take the snapshot of this. Now you have to write this readings. Inverting configuration. This is the circuit diagram. And let us show the output. Cursors are shown and it is marked. Understood inverting and non-inverting configuration. Now we will see one more practical, that is, I stopped here. Op-amp as triangular and square wave generator. Last time we have conducted an experiment called as Smith trigger, okay, which was generating the square wave. Now we will see how op-amp can be used to simultaneously generate two waveforms. One is square wave and another is triangular wave. Just a minute. Is my screen visible to you? On my mobile it is not visible to me. Is my screen visible to you?
Yes, ma'am.
Yes, ma'am.
Somebody I think is removed by mistake. I don't know. My mobile is not operating. If someone has been removed by mistake, Please log in again. Okay, started now. So now we will see uh, OPAM as waveform generator. I'll use another. Again, we will use OPAM here. Put analyze OPAM, place analog, use I741. Then I need two resistances. So I'll go to resistance symbol, place basic, then here I will choose a resistor. This is resistor family. You choose by default 1K is selected in this window. So let's take it 1K. Then further things, I will copy the same. Okay, so we will now ground this positive terminal, sorry, and negative terminal, inverting terminal. Circuit diagram from the same. So inverting terminal, you have to ground it. How I am drawing the circuit diagram, just see. Then to the positive terminal, I am connecting a voltage divider network such that the resistance, let's call this, of 10K is used as a feedback. So I'll make this as 10K. It is connected between pin number 3 So this resistance is connected between input and output. So this is your feedback resistance 10K. This is another resistance which is 1K. This is 1K. And it is, now we have to use two stages of OPAMP. This is first stage and this is second stage. Okay, two stages. The output of one stage we will give to input of another stage. So first stage is a square wave generator. Okay. Now this resistance we will give it to the output of second OPAMP. So instead of connecting this is R2 is connected to pin number 6 of second stage of OPAMP. Now let us connect the output of first stage to the input of second stage. The second stage is an inverting amplifier. So I have to give input to the pin number 2. So I will use here a resistor. and the value of this resistance is 15K. Design I will be explaining you in the theory lecture. This is 15K resistor connected to the inverting terminal of second stage and the output terminal of first stage. Now second stage what we have to use is a integrator. First stage will be generating here, the first stage of Smith trigger will be generating the square wave, and the output of first stage, which is square wave, when it is given to the integrator, it will integrate it and it will provide us the integration of square wave, that is triangular wave. Okay, so the remaining pin here we are supposed to ground. Pin number 3 shall be grounded. Okay, now we are not connecting any function generator. This is a waveform generator. So what waveform generator do? It automatically generates the waveform. It does not require AC signal for its operation. Only DC power supply we have to connect. Now let's connect the DC power supply. So which are our pin for positive supply? Pin number 7 is for positive supply. So let's connect positive supply to pin number 7. This is our pin number 7. Can you see this? I will zoom. This is pin number 7. So I'll be connecting plus VCC here. I'll go here to the power source and I will connect VCC. Okay. The default value is 5 volt. Let's make it 15 volt. So this is, I will make it 15 and I will make this as minus 50. I have to connect negative supply to pin number 4. This is pin number 4. So here I will connect negative supply. Let's flip it and connect it to pin number 4. And this I will connect to pin number 7. Now you can connect the same things here, or you can simply connect pin number 7 here and pin number 4 here, so that both are sharing the same supply voltage. Let's use oscilloscope, put here. Let's first check whether you are getting the output. Let's check the connection once again. Positive terminal is connected to 10. Between positive and output, pin number 3 and pin number 6, there is 10K. Then I need to place a capacitor at second stage because it's an integrator. So see the feedback path, that is inverting terminal and output. So you need to connect a 0.1 microfarad capacitor. So go to the basic capacitor and 0.1 microfarad capacitor you can place here. So where to place it? Between pin number 2 and 6. Connect this terminal here to check the second output and make the color of second output with so now we will make the scale of both as 1 volt. One volt, and here also 1 volt. I'll enlarge the input. Run and pause. Because your square wave is exceeding, so I will increase its voltage. Now you see, we got two output. One is red color, which is at the output of first stage, that is square wave, and another output we are getting triangular wave, because first is a Smith trigger stage, comparator stage. Second is a integrator stage. So integrator stage will integrate the square wave and it will provide the uh, triangular wave. You can shift this wave. I can change the position. Move this first wave above. It is 1 here and it is -1. So position I am changing. So two type of waveform you are getting, or you can check it combinedly. Okay, so let's take the screenshot of this and paste it. And of course you have to measure. So you please measure, put your cursor and measure the output. So bring the cursor 1 at negative peak, cursor 2 at positive peak, and measure the input, measure the output voltage of square and triangular wave according to the channel. So paste it here. and paste the circuit diagram. Okay. So this way you have to complete and write the result in the experiment. The setup I will send to you because I have a meeting. I will not exceed this meeting. Have you marked your attendance?